evaluate the integral by making the given substitution. So the integral that we have is e to the negative x dx, and we're going to let u equal negative x. So for the first part, what we're going to do is they're telling us that we're going to let u equal negative x. Okay, now what we're going to do is we're going to take the derivative of both sides of this equation. So the derivative of u is going to be 1 du, and the derivative of negative x is negative 1 dx. Okay, now we want to be able to solve for dx because that's what we're going to be substituting back into the original integral. So therefore, if we either multiply or divide both sides by a negative, we're going to get negative du, and that's going to equal dx. So that's going to be our substitution. Okay, so now let's take a look at the integral itself. So the integral is given to be e to the negative x dx. And now we're going to apply our substitutions. So the first substitution is that we know that u is equal to negative x. So now this is going to become e to the u. And then we also know that dx is equal to negative du. So this is e to the u times negative du. Okay, and so now what we're going to do is we can now factor out the negative. So we're going to factor out the negative, and then what's left is e to the u du. Okay, and then what do we know about taking the antiderivative of e to the u? Well, the antiderivative of e to the u is e to the u. So therefore, this is going to be negative e to the power of u. And because this is an integral, and we're going to go ahead and then add the constant plus c. And now what we're going to do is now do the final substitution. So we know that u in step number 1 is equal to negative x. So therefore, this is going to be negative e to the negative x plus c, and therefore that is your result.